Hello guys, in this video we'll be discussing about the question first index and last index of an array. So here in the question, let's consider an array of size 10. An array will be given which have duplicates value. Right? This array will have duplicate value. One, two, three, four, five, six, seven, eight, nine, 10. Right? This array will have, and it will given a value 20. Right? Let's consider the value is 20. Now we have to find the first index and last index of our value 20. Right? What is the first index of 20? This part. Last index, this part. The first index is 3, last index is 6. So for value 20, first index is 3 and last is 6. Right. Here we should not use linear search, because if you use linear search, the time complexity will be more. We need to check every element. So try to use a binary search to find out the first index and last index of the given number. Right. Now let's move to our solution. Let's erase this. Let's take some values. And these are the value. Now we need to let's try to find the last index first. Right. For finding the last index, let's consider the given value is 20. Right. We need to find the last index of 20. Here we'll be using the technique of binary search. That is, this will be low, this will be high, right? This will be our mid. Right, this will be our mid. These are the indexes. Right. In binary search, when the mid is equal to our data, we just print the statement and we return it. We don't need to go for more loop. Right? We don't need to go execute any other loop, because when we found the element, we just return it. But here, when we find the element, this element can be our last index. Can be. We are not sure that it will be our last index, but can be our last index. So this is a potential candidate. Potential candidate for our last index, but we are not sure that it will be our last index or not. So instead of returning, when the data is equal to mid, in simple binary search, we just return it. But here, instead of returning, we assign it to our last index, that is mid, and we move our low to mid plus 1. Right. Why we are moving this? Because we know that this can be our last index, but we are not sure that this will be our last index. We are trying to search for more last index. That is there any element present after this? If it's present, then that will be our last index. This can't be, right? So this is our potential candidate. Potential candidate, not the exact last candidate. There is last index, right? Not exactly last name, potential candidate for a last index. So we'll try to do a dry run for this code. Are you all familiar with this binary search? What are the other two conditions for binary search? That is, data is less than mid. That is, if data is less than mid, then high will be mid minus 1. And data is greater than mid, then low will be mid plus 1. Right. These are the condition. Only the last condition change this condition. That is, we are just finding the potential candidate for our last index. We don't know exactly that it will be our last index or not. That's why we are just assigning and we are moving our low right here. So in this, let's drag this down. Now mid is here or data is here. Now we have found our last index. Now last index is potential candidate. Potential candidate or last index is 4. Right? Index will be stored 4. Again, this low will move here. Low is moved there. And what will be the mid here? Mid is this point. We'll check. Our value 20 is less than 30. Less than mid. If it's less than mid, then high will become mid minus 1. Then high will come here. Right? This will be high. Again, we'll find mid here. What is mid? Mid is this point. Right? Mid is equal to our data. If it is equal to data, then our last index value will be updated with 5, and this low will move to mid plus 1. Right? This point. Now this is our mid. Again, we'll check if mid equal to our data. Yes, it is equal to our data. When it is equal to our data, we got our potential candidate and another potential candidate. That's why we'll update this with 6. Right? Then 6 is the index of our mid. Now after updating, we'll also update low. There is low equal to mid plus 1. When low comes here, there is high and low cross each other. That is, now low is greater than high. When low is greater than high, our binary search condition won't be satisfied. Then it will come out of the loop, and we got our last candidate, last index. That is our potential last candidate. That is our last index. We got our last index. That is the last index is 6. Right? This is the last candidate for our last index. Then this will be our last index. These are the potential candidates. 4 was potential candidate, 5 also. After that we got 6. That's why 5 got updated to 6. So this is how we try to find the last index using binary search. Now we'll try to find the first index using binary search. For first index, we just need to update the high to low and low to high to mid minus 1. Right? See here. So we need to find the first index. Now first index is consider initially first index is minus 1. Here when data is equal to mid, we'll store our first index, the potential candidate for first index, that is mid, and we will update our high to mid minus 1, because similarly to our last index, this will be our potential candidate for our first index. Before when we are doing last index, we store our potential candidate for last index here and we'll update our low. But while finding first index, we'll store the potential candidate for first index and we will update our high to mid minus 1. Sorry, this will be mid minus 1. Right? So let's try to write on this code again. Now high, mid is here. When mid is equal to our data, it will be our first index. First index is 4, right? Now the potential candidate for first index become 4. Now we'll move our high to mid minus 1. This will be our high. When we found our potential candidate, we just don't return it. We move our high to mid minus 1. Then again we'll check for if there is any candidate present that can be our first index. We'll be checking that. Now we'll find mid here. Mid is this point. Right? Now data is greater than mid. If data is greater than mid, low will be shifted here. Again we'll find our mid index here. Mid is here. Now data is greater than mid. Again low will be shifted here. This is simple binary search. Now mid is here. Now mid is equal to data. When mid is equal to data, our first index will be updated with the mid value. That is 3. We got our another potential candidate. Now after getting high will move to mid minus 1. This high will move to mid minus 1. When high moves to mid minus 1 here, high and low cross each other. See here, high and low cross each other. That is, low is greater than high now. Then our binary condition doesn't satisfy. So we'll come out of the loop. We got our final candidate, that is 3. 3 will be our final first index. First index is 3. For 20, first index is 3 and our last index was 6, right? So we try to write this in our code. We'll be taking inputs. This will be our size of an array. This is our size of the array. Now we'll take input for our array. This is input for array. I equal to 0. This fold will be taking inputs. So ARR of I. In ith index, we are storing the input. Now we'll take the data. For this data, we have to find our last index and first index. Now data. So for binary search, we need to take our low and high, right? Low is 0 and high is length -1 and -1. And initially we'll keep our first index equal to -1 and our last index will also be -1. Initially we'll keep last index and first index -1. Now we'll do for loop. No, not for loop, we'll run our binary search, modified binary search for finding first index. First we'll find first index. So what are the conditions? First we'll calculate our mid. Mid. The conditions, so what are the conditions? The condition are data is less than array of mid. This will be our condition. Else if data is greater than array of mid. Else when data is equal to mid, what should we do? First we'll try to write here simple binary search algorithm. The first two condition will be same as simple binary search. This when data is less than mid, then high will equal to mid -1, right? When data is greater than our mid, then low will be equal to mid +1. So when data is equal to our mid, that is when we got our potential candidate. When we got our potential candidate, we assign that candidate and we update our high value to mid -1 for checking that if any other candidate is present or not, right? So we got our, after this loop we'll get our first index. Similarly to this, the code will be same for last index. We just need to change on two line. That is, instead of writing first index, we write last index here, and instead of updating high when we got our potential last index, we should update our low to mid +1. That is, we'll be checking our right side so that if any other last index candidate may present or not, right? Now we got our high and low. We'll check whether they are printing. So they are printing first index first and low last index last. Later. So after this we got our high and low. High, not high and low, first and last. First index is stored in F5 and last index is stored in LI. Right here I'll be printing the first index first. F5 is our first index and system.out print ln is our last index. Right. We'll run this code and we'll see if we're getting the correct answer or not. It's giving wrong input. Last index. We are not getting last index. Li is equal to low is equal to mid +1, then y. So again we need to initialize our low and high with 0 and right. So after this loop, our low and high value will be crossing each other. So we need to initialize our low and high value with 0, low with 0 and high with erasure length -1 for new binary search. Again we'll check this. Now we are getting the correct answer. The mistake was that after running the binary search for first index, our high and low value was changed. So after that we need to update our high and low value to 0 and lowest 0 and highest our error size -1. So after that again we need to do the binary search, modified binary search for last index. Now we got a last index and first index. So we'll try to submit this code. So the solution is correct. I hope you understand this solution. Thank you.